Hi, I'm Swarupa Sail, course instructor for fluid mechanics. In this presentation, we will solve problem based on momentum principle. A 500 mm pipe carrying 0.8 meter cube per second of oil of specific gravity 0.85 has a 90-degree bend in a horizontal plane. The loss of head in the bend is 1.1 meter of oil and the pressure at the entrance is 290 kPa. Find the resultant force exerted by the oil on the bend. The pipe is of uniform diameter, so diameter at section 1 and at section 2 is equal to 500 mm, which is equal to 0.5 meter. Area at section 1 and 2 is same, so A1 equal to A2, which is equal to pi by 4 d square. D is 0.5, so we get A1 and A2 as 0.19635 square meter. Discharge Q equal to 0.8 meter cube per second. Velocity at 1 and 2 equal to V1, which is equal to Q by A1. Q is 0.8 and A1 is 0.19635. So we get Q divided by A1 as velocity V1, which is equal to 4.07 meter per second. Pressure at section 1 P1 equal to 290 kPa, which is equal to 290 into 10 raised to 3 Pascal. Loss of head equal to 1.1 meter. Now we will use Bernoulli's equation to find out the value of P2, which is not given in the problem. We will apply Bernoulli's equation at section 1 and section 2. So head at section 1 equal to head at section 2 plus the losses. Here we have considered head loss as the value of HL is given. In previous problems we had considered HL as equal to 0, considering no losses. So P1 by W plus V1 square by 2G will be equal to P2 by W plus V2 square by 2G plus HL, considering Z1 equal to Z2, that is distance between datum line and the center at section 1 and section 2 be same. P1 is 290 into 10 raised to 3 divided by W of liquid. W of liquid will be specific gravity of liquid into specific weight of water. So specific gravity is 0.85 into specific weight of water is 1000 into 9.81 plus V1 is 4.07, G is 9.81. P2 has to be found out. W is 0.85 into 1000 into 9.81 plus V2 is 4.07, G is 9.81 and HL is 1.1. With this we get P2 as 280828 Newton per square meter. Sum of the forces in x direction is equal to rate of change of momentum in x direction. So force in x direction is P1 A1 minus Fx equal to rho QV. Rho QV is rho into Q into change of velocity, that is V2x minus V1x. So P1 A1 minus Fx equal to rho Q into V2x is 0, that is velocity at section 2 along x direction is 0 minus V1x. So we get Fx equal to P1 A1 plus rho Q V1x. P1 is 290 into 10 raised to 3, A1 is 0.19635 plus density is 0.85 into density of water. Q is 0.8 and V1x is 4.07. So Fx equal to 59709 Newton. Now we will find out Fy. So sum of forces in y direction equal to rate of change of momentum in y direction minus P2A2 plus Fy equal to rho q into V2y minus V1y. So minus P2A2 plus Fy equal to rho q into V2y minus 0. So we get Fy equal to P2A2 plus rho q V2. P2 is 280828 into A2 is 0.19635 plus density of liquid is 0.85 into density of water. So it is 0.85 into 1000 into Q is 0.8, V2 is 4.07. So we get Fy equal to 57908 Newton. And the resultant force F equal to square root of Fx square plus Fy square, which is equal to square root of 59709 square plus 57908 square, which is equal to 83177 Newton. And theta equal to tan inverse of Fy divided by Fx, which is equal to tan inverse of 57908 divided by 59709, which is equal to 44.1 degree. Now we will solve one more problem. The discharge of water through a 130 degree bend is 30 liter per second. The bend is lying in the horizontal plane and the diameters at the entrance and exit are 200 mm and 100 mm respectively. The pressure measured at the entrance is 100 kN per square meter. What is the magnitude and direction of the force exerted by the water on the bend? So the given data are diameter at section 1 d1 equal to 200 mm, which is equal to 0.2 meter. So area at section 1 will be pi by 4 d1 square, which is equal to 0.0314 square meter. Here diameter of the pipe is decreasing from section 1 to section 2. So diameter of section 2 is 100 mm, which is equal to 0.1 meter, and A2 will be equal to pi by 4 d2 square, which is equal to 0.00785 square meter. Discharge Q is equal to 30 liter per second, which is equal to 0.03 meter cube per second. Velocity at section 1 V1 equal to Q by A1. Q is 0.03 divided by A1 is 0.0314, which is equal to 0.95 meter per second. Velocity at section 2 V2 equal to Q by A2, which is equal to 0.03 divided by 0.00785, which is equal to 3.82 meter per second. Here the bend is 130 degree. So 130 degree is considered from horizontal positive x direction. So theta will be 180 minus 130, which is equal to 50 degree. Pressure at section 1 P1 equal to 100 kPa, which is equal to 100 into 10 raised to 3 Pascal. We need to find out what is resultant force exerted by the oil on the bend. We will use Bernoulli's equation, that is head at section 1 equal to head at section 2. And we will consider Z1 equal to Z2. So we get P1 by W plus V1 square by 2G equal to P2 by W plus V2 square by 2G. P1 is 100 into 10 raised to 3 divided by specific weight is equal to 1000 into 9.81. V1 is 0.95, G is 9.81. P2 has to be found out. W is 1000 into 9.81. V2 is 3.82 and G is 9.81. So once we calculate, we get P2 as equal to 93155 Newton per square. To find Fx, we will equate sum of forces in x direction to rate of change of momentum in x direction. So forces in x direction are P1A1 plus P2A2 cos theta minus Fx equal to rho q into minus V2x cos theta minus V1x. So Fx will be equal to rho q into V1x plus V2x cos theta plus P1A1 plus P2A2 cos theta. P1 is 100 into 10 raised to 3, A1 is 0.0314 plus P2 is 93155, A2 is 0.00785, theta is 50 plus rho is 1000, Q is 0.03, V1x is 0.95 plus V2x is 3.82 and theta is 50. So, after substituting, we get Fx equal to 3712 Newton. To find Fy, we will equate sum of forces in y direction to rate of change of momentum in y direction. So, minus P2A2 sin theta plus Fy equal to rho q into V2y sin theta minus V1y. So, Fy will be equal to rho q V2y sin theta plus P2A2 sin theta. So, after substituting the values, we get 93155 into 0.00785 sin 50 plus rho is 1000, q is 0.03, V2y is 3.82 and theta is 50. With the values, we get Fy as equal to 648 Newton. V1y is equal to 0. These are the references. Thank you.